Okay, today we are going to discuss sustainability through the lens of transportation. Now, obviously, this is a very broad topic and one that touches every person. We're all focusing on transportation and also a topic that's changing rapidly currently in our world, moving toward electric vehicles, commuting, working from home, ordering groceries to the front door instead of driving to the grocery store yourself. Many things are changing as far as how we move ourselves and our things around in the world. But that being said, there are still a few traditional ways we can look at transportation kind of on a fundamental level and think about it through the lens of sustainability. So let's do that now. So here we go with our lesson of the day, sustainable transport. And remember, this is the introduction. So we'll start off with a few facts. Transportation accounts for roughly 1/4 or 1/5 of the world energy consumption and CO2 emissions. And 97% of those, the vast majority, almost all of those, come from directly burning fossil fuels. If you recall a few weeks back when we looked at the diagram of where energy is produced and where it is consumed, there was that thick band of fossil fuels that comes straight out of the earth, gets refined, and then used in transportation, not generating electricity. This sector is increasing at a very fast rate, faster than other energy using sectors. Road transportation is a major contributor to the local air pollution and smog, as well as the global air pollution of CO2. And the United Nations Environment Program estimates that each year, 2.4 million premature deaths from outdoor air pollution could be avoided. Let's take a look at air pollution. Now, air pollution, there's several different elements or molecules that scientifically are considered air pollution. And those are mainly the things that will cause a harm to human health. If you recall the planetary boundaries, the buildup of greenhouse gases is one of the thresholds that we don't want to go past. So CO2 and CO2 equivalent emissions are a form of air pollution, but there are even other types of elements, things that come out of tailpipes, power plants that burn fossil fuels. They're directly harmful to human health. Even things like ozone. So ozone is valuable up in the atmosphere, but down at low levels, it's harmful to human health. And so here we can see a map that is showing the state of California, broken up by county, roughly by county. Technically, it's by air district. And regular measurements are taken to provide a score for the air quality in the state. And if we take a look at this map, we can see that there's a general geographic kind of disparity. And we've got the green. Green is good. It meets the standard. And then as we move into the darker red colors, it gets to severe and extreme. And if you take a look, where is the most extreme negative air quality? Well, it's in the San Joaquin Valley, primarily due to the agriculture, the dust that is kicked up. Dust in and of itself, if it is a very small particle, a couple of different particle sizes can cause harm to your lungs. And so in our southern deserts, the Mojave Desert and the South Coast, as well as the San Joaquin Valley, we have dust storms that can severely impact human health. In addition to the dust, maybe there's some speculation about fertilizers or pesticides drifting and things like that to also consider. And then take a look at the northern area where it's the moderate. And I would have to do a bit more research to look into this, but you may suspect that the fires that have been taking place over the past several years might be contributing to some negative air quality there, the smoke from the fires, and it still is in the Great Central Valley as well. Now we take a look down at Southern California, especially on the coast. The South Coast in LA and Orange County, as well as San Diego County, are typically pretty poor air quality. And depending on the data, depending on the year, they can give you a score, a grade, and many times Southern California gets a failing grade. And it's largely to do with the urban environment and the quantity of cars. And especially in San Diego, we can think of several areas where maybe there's a ton of vehicles idling all the time. Our freeways, for example, in traffic. And all of those idling cars or driving cars, they emit emissions that are harmful to human health. Interestingly, in San Diego, where is the worst air quality? Well, it's not right on the coast where all the cars are, because the wind from the ocean blows all of that air inland until it goes up in elevation, but it doesn't go all the way past our mountains. So halfway up the mountains, right around Alpine area, there is what's called an inversion layer. The air gets blown in, but can go no further. And there's a thick band of air where all of the air pollution from the coast kind of settles. So the worst air quality in the county is in our inland foothills. So let's take a closer look at this burning of fossil fuels. When we burn fossil fuels, or when there's forest fires, the smoke, it is basically carbon that's up in the air. And this carbon is a component of particulate matter, which is a known cause of respiratory and carcinogenic diseases, and a significant contributor to global climate change. And this is basically smoke. Now, when smoke is diffuse and spread over a broad area, it becomes more like a fog. And have you caught that that's what the word smog refers to? Smoke and fog. Here we see the city of San Francisco with some smog on the horizon. Naturally, it's a foggy area, and when the smoke gets trapped there, you've got the smog, and that particulate matter, the smoke, the black carbon in the air, is harmful to human health. So what have people done to try to alleviate some of this smog? Well, you may be surprised to learn a little bit more about the catalytic converter. In California, one of these is required on almost all vehicles, except for the very old vehicles that were produced before a certain date. Everything else needs a catalytic converter. So what is happening in a catalytic converter? Well, you can see this diagram showing the exhaust gas coming out of the engine is made up of hydrocarbons, which is just burnt oil and fuel, carbon monoxide, and nitrogen oxide. And there's a few other nitrogen oxides that are harmful. What happens is those get released, and then they either bind up with other elements causing human health, or they pollute the environment. We want to limit all of those. And so the device, the catalytic converter, passes this exhaust through a material, a honeycomb-like material that is made of certain elements that react to the exhaust and make them more inert before they go out into the environment. And so you can see the blue arrow showing the tailpipe emissions. All we ever really get out of the car now with a catalytic converter is water, water vapor, carbon dioxide, which is CO2, and nitrogen, which is N2. Nitrogen in the atmosphere is not a problem. The CO2 is a greenhouse gas, but it is still better for human health than the carbon monoxide. And the H2O will contribute to greenhouse gases in the form of water vapor, but it's generally not harmful. So you can imagine the great work that the catalytic converter is doing. And this is why we need to get a smog check on a vehicle in California to verify that this device is still working. And this is why we require catalytic converters in the state of California. When you really understand what's going on, you realize, oh, this is a great thing, and let's keep it up. There are other issues to think about with regard to sustainability, health and safety, and vehicles and transportation. So of course, we have the potential for accidents. There's the issues of physical inactivity that we are thinking about. People sitting for long periods of time, especially those people who drive for a living, can actually end up with pretty unhealthy working conditions, a lack of mobility because you're driving so many hours. Recognizing that there's a time cost to commuting, and so people spend lots of time on the road driving to and from work. Now, again, this is changing perhaps due to Zoom and the nature of teleconferencing and working remotely, working from home, but we still end up moving people around quite a bit. And considering the increases in fuel prices, the economics, in addition to the environmental impact. All of these forces are always at work, and we're trying to consider the big picture when we think about the total price we pay for our transportation. Certainly right now, fuel prices are at a record high, and they go up and down, kind of fluctuating with economics and politics of the day. But certainly we can expect fuel prices to generally increase over time as a non-renewable resource tends to run out. Of course, we have traffic congestion and potential issues with so many vehicles taking up so much space, especially in a concentrated urban area where lots of people are trying to move around. And we're even seeing cities move back to car-free areas. So kind of saying that the cars should stay outside of the city or at least off of certain streets and give that area back to pedestrians or bicycle traffic. And maybe we can have a better way of life if we avoid some of this traffic congestion. Now, when we think about these negative impacts of the traffic, the health impacts, and the time requirements, the fuel prices, all of these things tend to have a negative impact mainly on the social groups that are least likely to own and drive the cars. So oftentimes the people living in the most polluted areas, they're the ones getting the worst impact from all these vehicles, but they're not necessarily owning all the vehicles. And similarly, the folks who take public transportation, they spend the most time out of their day. They don't have the quick convenience of driving to and from areas, but they pay in their time. And so we have this kind of disproportionate impact. There's a socioeconomic disparity in how who is emitting the fossil fuel emissions and who is receiving the hurtfulness of it. And so we think about that as well when we try and understand possible solutions. So this brings us to sustainable transport. And basically, we're considering modes of transport and systems of transport planning, which are consistent with the wider concerns of sustainability. Remember, we define sustainability with a triple bottom line. It's not just about the profit. We also need to consider people and planet. So a sustainable transport system will allow basic access and needs of individuals, companies, and society to be met safely and in a manner consistent with human and ecosystem health. They need to be affordable. It needs to operate fairly and efficiently and offer a choice of transport mode and support a competitive economy all at the same time. And it needs to limit emissions and waste within the planet's ability to absorb them. So it needs to be using renewable resources at or below their rate of generation and using non-renewable resources at or below the rate of development of renewable resources, while minimizing the impact on the use of land and the generation of noise. A tall order, to be sure. So what can we do? Well, there's kind of two strategies, and we're seeing both of them take place currently. The short term is fuel efficiency and vehicle emissions controls. And the long term is migrating from fossil-based energy to alternatives, such as renewable energy. So we can do a lot of things to regulate vehicles. We can require certain fuel efficiency standards. We can check and verify that each year, or I guess every 2 years, to renew your vehicle, you need to pass a smog check. That's the short-term goal. Let's get the polluters off the road, and let's work toward increasing fuel efficiency and vehicle emission controls. The long term, and we are seeing long-term goals being set, especially in the state of California, shifting all new vehicles from fossil-based fuel to alternative fuels, including electric vehicles. We've got kind of a dual strategy here. And the important point is that we want to be working on both at the same time. And it may not be feasible overnight to just go 100% electric. Where are we going to get that extra electricity? And is that electricity going to be generated in a non-renewable fashion? So it's going to take some time to have a fully renewable or sustainable transportation system, but we do need to work there. And in the short term, we can still promote fuel efficiency and reduced emissions. So some of the more specifics, how would we meet those goals? We can try to reduce the weight of vehicles. Surprisingly, the weight has a big impact on the fuel consumption of the vehicle, which is why the smallest cars out there, including some things called smart cars and things like that, tend to be much more fuel efficient. Less weight to push, so less fuel to burn. It's pretty much that simple. You can see a little breakdown here, a couple years old, of various makes and models of vehicles and how they fall on the fuel efficiency scale as related to their weight. And ultimately, we can see that the heavier vehicles will consume a lot more fuel. We live in a free enterprise system, and so people get to pick and choose what they want to drive. A lot of people attach their personal identity with what they drive or with what others drive and kind of make judgments about who you are based on what kind of car you're in. Well, you can see this graph is showing that these vehicle manufacturers understand that, and they know that people want to make choices about driving a big truck or a little car. So what we're seeing here is a planned reduction in the weight of the vehicle without making the vehicle physically smaller. Kind of interesting that people still want them to look big, but they can still be lighter along the way. The way we drive definitely has an impact on fuel consumption. One thing that can be done is drive slower. Once we drive quickly, we burn more fuel. In the 1970s, there was a fuel shortage in the US due to political issues. And one of the strategies to alleviate this was to reduce the speed limit on freeways down to 55 miles per hour. And when that happened, it caused a dramatic decrease in fuel consumption. Once the fuel shortage lifted, people wanted to go fast again. So they raised those speed limits back to 65 or 70. But driving slower saves on fuel. Technically, if you're in a vehicle with multiple gears in the transmission, the most efficient is the slowest speed in the highest gear that the vehicle can safely travel in is the most fuel efficient. The engine is running the lowest. Then take it easy on the brakes. Every time you use the brakes, you're basically saying that you pushed too hard on the gas. So of course, safety and common sense. We have to be courteous to others is important, but generally trying to coast to red lights will reduce fuel use. And then, of course, having gas-efficient vehicles, including electric vehicles, will help you to save on fuel cost. Even simple things like keeping tires inflated and reducing the friction of tires overall with a tread pattern that is meant for the season and for the street type that you'll be using will contribute a lot to fuel efficiency. And then we can, of course, encourage electric and hybrid vehicles. Now, electric vehicles don't have an engine. There's no internal combustion engine. There's no gasoline. There's no fuel. There's no oil. It's just a motor. A motor is very similar to how we've discussed electricity being generated in previous lectures, where we've discussed a coil and wires and how we can get electrons to flow. And we can store that electricity in a battery system to be used when necessary. And so you can see the diagram up above shows a plug-in electric vehicle with a battery system and electric motor. Very simple. That's how they work. And the hybrid vehicle is an old-fashioned traditional engine with internal combustion. However, whenever you apply the brakes, that energy that would normally be lost in friction, the heat given off by the brakes, is actually captured into a generator that is stored in a battery. So you've got a combination, a hybrid between an electric motor helping to assist the fuel engine, the internal combustion engine. So it makes the engine much more efficient and makes your car much more fuel efficient. So of course, these are both excellent strategies, and the hybrid is kind of a good transition vehicle into an electric vehicle. And then of course, how can we avoid the vehicles altogether? We want to always be improving the walking and cycling ability of the environment. You can look up neighborhood walkability scores to see how close your home is to various groceries and entertainment places. You can try to live closer to work. And in general, cities can do a lot to try to alleviate traffic and safety issues by encouraging walking and cycling. And one example here is a dedicated bike lane, especially one that is separated by a physical barrier from traffic. Similarly, companies can give incentives to their own employees. They can provide showers. They can allow for flexible schedules, all sorts of things to try to allow for people to incorporate walking and cycling into their daily lives and not force them to rely on the car. And additionally, enhancing the role of public transportation, especially electric rail, because it's efficient and it doesn't use fossil fuels. Notoriously, the problem with public transportation is what they like to call the last mile. So how you get to and from the bus stop, the bus doesn't drop you off exactly at work or home, so you need to walk there a little bit more, and it adds inconvenience and time. And additionally, you have to stop at everybody's stop and not just your stop. So there's some inconveniences here. So how can we try to make the public transportation, which is much more efficient per person, a little bit more rapid or a little bit more efficient, provide more routes, provide shortcut routes or rapid transit routes, things that go to and from cities that are commonly traveled, and maybe how can we incorporate the walking and bicycling in with the public transportation. All of these are difficult challenges, things that have their own specific solutions in local areas. Of course, in San Diego, we have virtually every kind of transport you can imagine, walking and cycling almost year round. We have bus systems, we have the light rail, trolley system, we have Santa Fe Railroad, so we have traditional style trains, We've got water taxis that take you across the bay. And of course, we have airports too. And so lots of transportation opportunities, but also challenges as we need to transition toward sustainable transport systems. So there's just a broad overview of the kind of thinking you would take to approach transportation sustainability. And I'd like to invite you to think about specific scenarios, your business, your company, your school, your neighborhood, your family, and how they may incorporate the goals of sustainability with regard to transportation. It's a really fun time to be considering this topic because every year it seems like we are sort of much further ahead than the year before as technology advances and things take place in the world that shift the economics or maybe change the variables, change the game, so to speak, and hopefully favor things towards a sustainable future. I hope you enjoyed learning a little bit about this topic, and I look forward to discussing it with you in greater detail in the coming weeks. Thanks a lot.